All right, there we go. So give me a few minutes to kind of digest this. The graph of a function is given. What is f of 2? 3. All right, so good. Just reminding us, we can evaluate a function, which, let's back up, is when you have an input that pairs with exactly one output. Okay. And how do we know a graph is a function? It passes the vertical line test. So we're looking at a function, and now we can evaluate it by saying, all right, you input 2, it outputs 3. So f of 2 is 3. Don't start. You were good all day. All right, so input 2, boom, outputs 3. That's all we're doing is taking the y coordinate there. What's f of 4?
Undefined.
Undefined. Great. So there's literally no output. This is kind of just like, doesn't go on forever. And reminding us of that. All right. Then let's carry on. Part B says let g of x equal f of x plus 5. So if we find g of -4, and let me take a moment to get these all the same size here. All right. Then we are simply saying this is f of -4 plus 5. Okay, maybe. There it is. And then we do a little bit of arithmetic. -4 plus 5 makes 1. And you just showed me in these opening examples that you can evaluate function f. So what is f of 1? 1. Cool. So keep that in mind. G of -4 outputs 1. We're going to need that in a minute or two if you haven't already read it ahead. And I want to get rid of some stuff here if it lets me. Maybe not. All right, we'll just go this way. Okay, what is g of -3? Well, it says take f, replace x with -3, and then add 5 to it. So that becomes f of 2. And f of 2 actually is right there screaming at me, outputs 3. G of -2 is f of -2 plus 5,
3.
which is 3, which outputs 3. All right, so if you got that far, well done. If you didn't, could you do it again now? So literally, when we evaluate a function, you replace x with the input, and even if it's like a new function from an old function, and that's kind of the way to think about it. This is Frank, this is Gary. So Gary is kind of related to Frank. Well, we're going to find that out now. But yeah, just substitute in the x with the number. And now I asked us to use these inputs. So now sketch y equals g of x using the information we just found, which was given -4, we output 1. Given -3, or if x is -3, we output 3. And given -2 or input -2, we output 3. We're going to plot 3 points. So this is this right there. This output 3. This one output 3. And stare at that long enough, and you just might start to say, wait a minute, what happened here? I got these 3 big bold dots right there. I got 3 dots right there. Take a little leap of faith, and I'm not lying to you, these would connect like that. And what do we see about this graph? How does this graph relate to F? Ooh, those are really fancy words, but you're absolutely right. It is a horizontal, minus horizontal means left, right? So it is a horizontal shift to the left. Perfect. And anyone want to take a guess exactly how many spaces? Or you could count 5 spaces to the left. Interestingly enough, we have this x plus 5 kind of vibe inside of F. We'll summarize this after the lesson, but take note of that, okay? So this is a shift 5 units horizontally to the left. And to further emphasize that, if you don't see it, we could literally go from here, 1, 2, 3, 4, 5 units left. 1, 2, 3, 4, 5 units left. 1, 2, 3, 4, 5 units left. We didn't do it that way to start. We actually plugged in numbers and showed that's what you get. Now, for instance, I'm going to drag this on a little bit further. What if I asked, what is g of -1? So, what's the output here at -1? Well, we would go to F, do -1 plus 5. Find that that's the output of F of 4. But in part B, at the top of the page, right over there, we said F of 4 is undefined. So kind of just giving further emphasis that this is definitely a shift. This is definitely a shift 5 units to the left. And we're going to summarize that at the end of this lesson. Cool. All right. I did ask you to correct this. So on your paper, that says G, but I fixed it on mine to say F. So make sure that does say F. Let's do this again. H of X is F of X plus 2. Inside of this grouping symbol, that's going to play a major role tonight, and -6. And so let me tell you right now, my objective tonight is kind of what we're doing. This is the exploratory phase. Some of us come into this class knowing this, remembering this. Some of us are completely like, I don't know what's going on. So it's a little exploratory, and then we'll definitely clean it up and leave us must-knows. Tonight's objective is function transformations. So shifting things, reflecting things, and something called stretching, which that seems weird, but we'll define that later, right? But really, at the end of the day, we have a graph, and we're going to transform it, just like the movies. No, I'm just kidding. Okay, so if I sub in h of -1, h of -1 says f of -1 plus 2, then -6. So this is f of 1 minus 6. So we already said now a few times, I can see right here, f of 1 is 1, and then 1 take away 6 is -5. So I'm going to plot that point right this second. -1 as my input, and then I'm going to output -5 as my y coordinate. So -1, -5 right there. See if this will cooperate with me. Nope, it still doesn't want to. Okay. I don't want to move. I just want to do this. Why is it shifting the screen? Okay, you win. H of 0. F of 0 plus 2. F of 2 minus 6. Remember this is grabbing F. Outputs 3 when we input 2. So 3 minus 6 is -3. Input 0, just to remind you exactly what we're doing. If you got it, cool. I want everyone to get it. We're outputting -3. And this is a new function. It's a transformation. This is Harry. That's Frank. Now we have Harry. Harry's a transformation. Okay, so 0, -3.
Where did that 3 come from? Yeah.
I don't know. That's a good question. Where did that 3 come from?
The function of 2 is 3.
So h of 0, boom, you submit a 0 here and here. Good with that? And now 0 plus 2 is 2. And did we actually answer this? Is this one of the questions? Yeah, it's right up here. So come on, now it's not scrolling. F of 2 is 3. So your question was, where did this 3 came from? From right above it. Frank, given 2, outputs 3. So I'm literally just writing the y coordinate on that. Is that clarified or not quite? Yay or nay? Maybe.
Yes,
Okay.
sorry.
So I lied when I said I don't know where it came from. I should have said I know where it comes from. So let's pause. I'll open it to the class. So we're taking the y coordinate, and then this -6 is just kind of coming down all along. So then lastly, 3 minus 6 is -3. So input 0, output -3, which I plotted right there. I'm already getting a vibe of what's going on here, but I'm going to further emphasize it by doing it out. H of 1 is f of 1 plus 2 this makes 3. And f of 3, again, I'm looking at it right here, little or Big Dipper, or almost little Big Dipper. Input 3, output 3. And that's the end of that story. So 1 outputs -3, 1 outputs -3. And those are 3 points on H. Just further emphasize it, here's Frank, the original function, F, and now Harry, or H, is over here. Clearly, there's been a transformation. That's what we mean. Transformation is something happened. Well, what exactly happened?
It's a vertical and horizontal shift.
So we are shifting once again, but not just in a horizontal manner. So we kind of think about, how would I move this collection of objects? Moving everything 1, pretty good. Not enough though. Moving it 2. All right, now it's in horizontal alignment. Moving it 2 units to the left. And then I'd be here. I want to shift it down 1, 2, 3, 4, 5, 6. Again, if you can imagine it, this is here now. 1, 2, 3, 4, 5, 6. It would be there. If you can't imagine it, I'll try to act it out with the laser beam. 1, 2 to the left, then 1, 2, 3, 4, 5, 6 would get us to that point. I'll do it one more time.
Should we write that?
Take this point, 1, 2, then down 1, 2, 3, 4, 5, 6.
Can I answer that question? We write it as like rise over run.
So rise over run refers to slope. This is referring to how we're shifting a graft.
But how I write it then?
We'll get there. In the exploratory phase right now. Okay, and maybe it's becoming a little less exploratory, and we're starting to build mathematical evidence. So if I look back at Harry, at h of x, suspiciously enough, there is a 2 and a 6, or -6, or 2, whatever we want to read it, in the function. If I scroll up to the top here, earlier, it was recognized that we had a horizontal shift 5 units left. What's going on now? We still have a horizontal shift, but not 5 units, 2 units left. And additionally, 6 units down. Who's catching what's going on here? Ish. Maybe, maybe not?
Yes.
Yeah? Feeling brave? All right, side story. Oops, that's not a marker. Come on. Side note. What do you think will happen to Frank's graph?
It's a horizontal shift 7 to the left.
All right, you can't answer any more tonight. Well, you are good. Yes. So there is a claim. We feel like this is going to be 7 units to the left. How can I almost emphasize that it is? Plug in some numbers. What numbers should I plug in? That's the new challenge. How can we definitely get numbers to work here? So I don't want to confuse us, but we know Frank it's his first output at 1. So what X will ultimately make this become the number 1? I want this ultimately to become 1. So what number plus 7 ultimately makes 1? -6. Does that make sense? Let's just talk this out. -6, smack it here, add 7 to it, becomes 1, and then f of 1 is 3. F of 1 is 1. So given -6, we would be outputting 1. And let's count 1, 2, 3, 4, 5, 6, 7 units left. All right, that is fact. We will write it up in a minute. This shifts 7 units left, or 2 units left, or 5 units left. Who thinks they can make it move 4 units to the right? Yeah, you're done. What do you think?
-4.
So now a new claim, X, come on, marker. Let's just talk this one out. F of X minus 4. So claim or vibe that this is going to shift Frank 4 units to the right. What number would I give that I would subtract 4 from to ultimately make 1? I'll say that again. Give me an X that I'm going to take 4 away from it, and it's going to make 1. 9. 9 minus 4. So if X is 9, you take away 4. Wait. No, 5. Okay. Why was I thinking 9? 5 minus 4 is 1. Cool. And f of 1 is 1. So given X is 5, it would output 1. And then we see 1, 2, 3, 4. Cool. I think it's so on point right now. We're going to write this up. Give me a second here. Come on. If you have your notebook or you wanted to take notes, we're going to title this Transformations So all I want to say so far is this. Suppose f of x is some function, some graph. That's all I'm trying to say. My goal tonight is to say, no matter what function graph you give me or that you see, goal number one is this. Then f of x minus h is a horizontal shift. To the left, if h is less than 0, and to the right, if h is greater than 0. Suppose we see this notation, f of x plus 3. And we're asked to identify the transformation. First question that we have to answer ourselves is, what the heck is the h value? And I'm going to let you think about that for a minute. So it's a little deceiving if it's x minus a number, then it's left if that number is negative, it's right if that number is positive. Carefully look at that. Here's an easier question. Maybe I should have started with the easier one. What is f of x minus 7? What's the h value here? -3. Why? Well, because if you sub in 3 here, what would that look like? X minus 3. And it doesn't look like x minus 3. So the answer, h is not 3. Try again. What would I sub in for h to make it look like +3, -3? Subbing in -3 would look like x plus 3. Who's with me? Because the keep change. So h is -3, which is less than 0. This is moving left 3 units. That's what your h value is. X minus h. H is -3, so it's left 3 units.
Would I run into any weird issues if, like, because I first interpreted it as, like, looking at the function, like, the notation that you have written, like, the f of x minus h, if the end result was, like, a plus, like, a positive or a minus, then it would either be left or right. Like, you know what I mean? Like, I kind of jumped it before I don't know if that's gonna.
Do you know, like, that notation means to the left 3?
Yeah.
Then cool.
Okay.
That's the most important thing.
Okay.
As long as you can say this is left 3.
Yeah, because like having a negative for the h.
Makes,
Yeah, I didn't really think about that part, but I'm already getting to that.
okay.
Part before I even.
If you know it's a left 3, that's the most important thing. As long as you can see that, or however your brain's internalizing, this notation means we're taking a graph and shifting it left 3.
I hate internalizing it when it's wrong.
Nope, if you're internalizing left 3, however you're internalizing is correct. All right, this guy over here, f of x minus 7, this is right 7 units. Since f of x minus 7, come on, we can see here h is 7. So the basic thing I'm trying to do is compare this structure. It has to be x minus a number. And the way to make a plus means the number has to be negative. I know it's a weird conversation, but we're over the hump if you can. This is like the most tricky part of the whole lesson, is right here, right now. When we see a plus 3, we have to internalize that's a left 3 units. I don't know how else to say it. It just is what it is. We've explored it, and it is what it is. So left 3. Now, when we see an x minus 7, we say the h value is 7, which is right, because 7 is a positive number, so we're going 7 units to the right. And that's why I had this. The main goal now is the transformation. First was internalizing the symbols. We're past that, I hope now. Now we're at the meat of the lesson, which is the transformations. So you can go back here and see what we did, why it is just how it works out.
Well, back to that, but is it the objective just to make 0 in the parentheses?
We can definitely, we'll get there too. Yep. I'll say that in a minute too. F of x plus some number. What's the difference here? The number we're adding is not inside the parentheses. This is a number outside, and this is a vertical shift. Up if k is greater than 0, down if k is less than 0. For example, that's not what I want. That's too bold, driving me crazy. This notation means we're not doing anything inside first. It's outside the parentheses. So this plus 7 will shift the graph up 7 units. All the graph, all the points. So this is going to shift. That's a way of looking at it. But shift up 7 since k is greater than 0. It's specifically 7. Here's the number being added outside. So this will shift down 8 since k is less than 0. Don't lose this yet. Hang on to it. But since we're in the core of this lesson, here's a new graph. Y equals the absolute value of x. Did we review absolute value yet in this course? I don't think so. But really quickly, what does it mean to do? Okay, it's the distance between 0 and that number. And I heard another word, always positive. Both of those are excellent. So just a quick reminder, if we had -2, if we had -1, if we have 0, if we have +1 or +2 or whatever, it means, think of 0 on a number line. How far is -2 from 0? 2 units to the right, but we don't care about to the right. And I know we're talking about transformations, but this right here just means 2 units. Or it means just make the friggin' number positive. It's 2 to the right. We don't care. This is 1. I'm sorry, I said to the right, but it's to the left. But that's 1 to the left. How far is 0 from 0? No distance. How far is 1 from 0? 1. How far is 2 from 0? 2. So at the end of the day, both those definitions work. It measures how far from 0. It also says keep everything positive. So now if we plot these points, -2, 2, -1, 1, 0, 0, 1, 1, 2, 2. If we actually graph these points, you get a V-looking graph. Just like that. Using your graphing calculator just to confirm this is just, I'll put that back up in a minute. Y equals ABS X. There you go. -2 outputs 2. -4 outputs 4. -6 outputs 6. 0 outputs 0. 2 outputs 2. 4. So you have this V-looking graph. That's another must know tonight. The graph of absolute value is a V-looking graph. Okay? Got to know that. That's another objective for the night. So now, identify okay. Try that again. Identify the vertex. From geometry, polygons like triangles and squares have a vertex, those little sharp points. Okay, algebra, some graphs have vertex or vertices. This one does, has a sharp point. Where? 0, 0. Next goal, if you can remember that the vertex of absolute value is 0, 0, you're golden. Sketch y equals the absolute value of x minus 3, then plus 2. And you're going to think about this as follows. What are my h and k values? And I really want you to do that right now independently. What are the h and k values? H is going to be the inside number, and k is going to be the outside number. You're going to turn to a neighbor in a second and compare your answers for h and k. If you're in agreement, that's your vertex, because that's your shift. 0, 0 is going to shift what h and k are. So the next step after you're in agreement with your partner or nearby neighbor is to create a table with 5 rows. And in the middle row, you're going to write the vertex. Go. I want to see where we're at here. What is the H? What is the K? What do you think H is? What do you think K is?
I was actually gonna ask you, what did you say about, you said something about K, I got K.
It's
What
not
did you say about
negative, right?
H?
Because we are.
We said,
I have, wherever it is, I have that.
so it's going to look like your inside, whatever your function is, in this case the absolute value, whatever's inside, it's going to have the form x minus a number.
Okay. Thank you.
So this does have the form x minus. So what's h?
-3.
Not -3. Who says h is just +3? Good. Because you're saying to yourself it's x minus. Oh, it is? Cool. When you can say it's x minus, there's your h value. It has to have the form x minus. If it does, you just say, there it is. So what's h? 3. 3 is a positive number, so we're moving to the right 3 units. What's the k value? That's outside. That's the outside number. +2. That's it. Your outside number, the outside is not the tricky part. +2, what do you associate with 2? Up, I hope. So 2 upwards. Okay. I asked you then if you're in agreement, which I heard some of us were, to create a table of 5 values with that vertex in the middle. 3 units to the right, 2 units up. What are a couple numbers around this x value? Well, I can think of a few. Let's keep them simple, and let's keep a few less than and a few more than. What's less than 3? What's less than 2? 1. So count backwards a little bit and count forwards a little bit. 4 and then 5. How do you find the rest of these outputs? I think the next and last easiest thing to do is just substitute in these numbers. 2, take away 3, -1. What's the absolute value of -1? Add 2 more, becomes 3. Which other value better output 3? Awesome. Just confirm that really quickly. 4 minus 3 is 1. Its absolute value is 1. Plus 2 more is 3. There's some symmetry going on there. Sweet. Sub in 1, take away 3, -2. Hit it with its absolute value. Becomes +2. Add 2 more, becomes 4. we know our work is 100% right. If we get the same number again, 5 minus 3 is 2, its absolute value is 2, add 2 more is 4. And if needed, which we won't do a lot of these, because I know you can plot points, but we'll just do a couple. Now you plot 5 points. 1, 4, 2, 3, 3, 2, 4, 3, 5, 4. If you had nice graph paper or online things, they'd line up perfectly. And even though you don't have access to online Desmos, we do right now, we can confirm that y equals absolute value of x minus 3 plus, what is it, 2. Here's the vertex of f. Here's the new rule. This is 2 units. This is 3 units right in the middle, and then up 1, up 2. Further emphasizing by clicking on the vertex. Your vertex is your h and k value. Pretty sick, pretty awesome. And now we're definitely into our lesson on transformations. We got a few more to get through tonight, but definite must-knows at this point. H, K, x minus h. X minus h. Remember that. So it has to look like minus on the inside. If h is positive, you're going to the right. If h is negative, you're going to the left. Cool. K is the outside number. Pretty less to worry about. When you see positive, you're thinking upwards. When you're seeing negative, you're thinking downwards. That's for all graphs. Next objective so far, absolute value is a V graph. Pretty simple to come up with a table of values on your own. We just did it. But the most important point there is the vertex. HK becomes your new vertex. That's how you shift it. And then around there, if you needed, and you will part of your homework, we're not going to do a lot of that in this course. Right now we do, just to kind of emphasize it. But if you needed to sketch a graph, you would just plot some points near it and off you go. Hey. All right. New rule. And new graph to know. Let me emphasize that. New graph to know. Y equals the square root of x. So for the next few minutes, we're going to learn this shape, and then we're going to transform it. And I'm going to have you do something independently, so you're not talking, or not me talking all the time. So we're going to learn a third shape, just to give you the rest of the 40 minutes. So we got a shape, we're going to practice transforming it. We're going to do one final shape, we're going to transform it, and then we're going to go back to that warm-up sheet and talk about a couple other transformations. So still a little bit to go, but you're leaving today with some shapes to know and transformations to be able to apply to any of them. So, what does this graph look like? I'll tell you, it looks like this. I could prove that to you by pulling up Desmos. I don't know how to call that shape. It's not a V. It's not a letter from our alphabet. It's the square root curve. That's what I'm going to call it. What are some important points on it? If you input 0, the square root of 0 is 0. If you input 1, its square root is 1. Can I give it 2? Absolutely. But I need a calculator because it's some decimal. What number times itself makes 2? Some decimal number. So what's another nice input? Cool. and its output would be 2. What's the next nice input? All right, you guys are vibing. You got it. So could we continue to do this all day? Yeah, we don't have to, all right? So as long as you got a few, it's all you need to be successful in this course and in calculus. Just know the main points, be able to recite them, and just generally know its shape. But the most important point to know of all of them is this. Just like the absolute value 0, 0, this point becomes our starting point. So absolute value had that vertex. I said that goes in the middle of your table. Well, when you're transforming a square root, this is going to ultimately become your h and k. That's the point that we're going to start. For instance, y equals x plus 2 inside the square root, inside the function, and then minus 1 outside. Inside, in general, we have to study and know x minus h. Does that look like minus? It looks like plus. So how do you make minus look like plus? This number is what type of number? Negative. Good, we're getting there. Negative what? 2. And negative you associate moving to the left. So this is going to go 2 units left and 1 unit down. That's the transformations. We already know it. If that's all that was asked, good. But let's build a sketch of it. -2, -1 becomes our starting point. I'll prove it to you when we look at decimals. Just trust me for right now if you don't. Here's the next thing about square root. What comes after 0? 1 unit ahead. So what's 1 unit ahead of -2? -1. You sub in -1, it becomes 1. Its square root is 1. And then you take 1 away from that, you output 0. Let's go back to this one. That was our start. The next nice input that I don't need a calculator for is 4 units ahead. What's 4 in front of -2? +2. Sub it in. Add 2 becomes 4. Sweet. Square root of 4 is 2. Take away 1 is 1. What's the next nice input? You got 10 seconds to figure it out if you're following what I've been throwing at you. It's not 3. Yeah. 9 away from your start. Okay, so the square root isn't impossible. It just takes a little bit of like understanding. These are the nice numbers. So you say to yourself, from my start, I want to go 9 ahead. Well, I have a new starting point. 9 ahead of -2 is 7. Sub in 7, add 2 becomes 9, take its square root becomes 3, take away 1 becomes 2. Sketch those points. If you had graph paper, obviously it'd be really nice, but we're just going to estimate 1, 2, down 1. Backwards 1 is 0. Then we go 1, 2, up 1, and then like 7, up 2. Yeah, it's weird for that reason, but that's really it. And if this was just cooperating with me, I would have passed through that point. So to further emphasize, let's see it nicely. Y equals SQRT X. By the way, you don't need to know the shortcuts that I know how to spell. If you wanted to mess around with Desmos at any point, whether in this class or outside, those tools like absolute values right there, square root is in here. And then when we get to trig, we'll see that there's other stuff in here, but the most common one's right there. And now if I say, all right, Y equals SQRT X plus 2, look at that. No other transformation. It just moves it 2 units to the left because H is -2. You're inside. It's X minus H. Then -1. I don't know what the heck I just did there. -1. I'm going to cover this up for a minute. See you later. We have all the points we just found. -2, -1. That's our start. -1, 0. We didn't input 0 because it was too hard to work with, but we did input, oops, missed it. It's all right. You get the vibe of this in a second, all right? We did input 2, which outputs 1. We did input 7, which outputs 2. And ultimately, it's that type of shape. I don't know how else to call it. Just the square root curve. All right. It's your turn to use Desmos. But before you do, and you might already know what this is. I hinted at it in this course. So you might have been sitting over the night I've already mentioned this course. Last graph to know tonight is Y equals X squared. So I will tell you, you should know 5 points on that graph. It also has a vertex at 0, 0. But there's a fundamental difference between the absolute value and the square root's curve. They have a lot of similarities, but not the same. So to be clear, for 5 minutes, you're reviewing or learning for the first time what the graph of Y equals X squared is. To do that, put 0, 0 in the middle of a table, sub in -1, sub in -2, sub in +1, sub in +2. Get those 5 points. Do not connect them with straight line segments. Connect them with a curve. You should end up with a U-looking shape called a parabola. More on that later. Just make sure you know that shape. And then I'd like you to graph using the same technique we've done so far. Y equals the quantity X plus 4 squared plus 1. Then lastly, go to Desmos, confirm your answers. Put Y equals X squared there and Y equals X squared, X plus 4 squared plus 1. Right, so take about 5 minutes. Also, if you need to stretch your legs, use the bathroom, something really quick, do that in the next minute and hurry back, right? So little independent time or neighbor time.
What was the other steps after -2 to get to this answer?
So you need to know on the square root, 0, 1, 4, and 9 are the numbers we can like take the square root of without a calculator.
Okay.
Those are just like the square root of 0, the square root of 1, square root of 4, square root of 9. So to get these numbers, here's our starting point. This is 1 ahead of it. So -2, 1 ahead of it is -1.
Okay.
Here's our starting number 0. This is 4 ahead of it. So if we count forward 4 from -2, It was 1, 0, 1, 2. That's how we got.
Oh, so it's
It would have been,
+2.
but you want to be able to get the right input values. Just going to put a little note over here. So the square root of x one, 4, 9. These were from our starting number, 1 ahead, then you add 3 to get to 4, then you add 5 to get to 9. Those are the next numbers. So you got to apply that same kind of thinking right here. You add 1 to -2, we'll make -1. Then you add 3 to that to make your 2. And then you add 5 to that to make 7. The reason we do that is because, for instance, what number did I not choose here? 6. Why didn't I choose 6? I could have if I had a calculator. 6 plus 2 is 8. The square root of 8 is not something I don't know without a calculator. That's why I didn't choose it. So don't go super crazy memorizing this. You're just trying to think about inputs that make this nice without a calculator. So -2 makes that 0. If we sub in -1, ultimately makes that become a 1. But that is the pattern if you wanted to like study something concrete. It's +1, +3, +5.
Thank you.
So some of us are still working, some of us are kind of looking up because we're at different points. You still got a couple minutes if you're working, but I am watching the clock like a hawk today. I want to make sure you get through what I need to. So in the background, 0, 0, still a vertex. It becomes a turning point, just like the absolute value that was like decreasing and increasing. We still have decreasing then increasing, but they're not straight lines, okay? You just make it curved, slow, smooth curve. Other than that, they have a lot of similarities. They both have a vertex at 0, 0. They both output 1, 1 and -1, 1. There is some other differences. The absolute value of 2 outputs 2, but the absolute but x squared outputs 4. So similarities, but not identical. It is a U-looking shape called a parabola. I believe I've already said that a few times a few weeks ago. So let me erase this for a moment. Actually, I'll just say these are the points to know. -2 squared is 4. -1 squared is 1. 0 squared is 0. 1 squared is 1. 2 squared is 4. Its shape, curved U shape. Don't make it look like a V. So on an assessment, if I can't tell, if I get asked you to graph absolute value and x squared, and they both have a sharp V, you're not getting points. So one is a sharp point, one is a curved point. Cool, that's x squared. Now, as I said, the main point of the night is transformations. If your brain is now seeing this as x minus a -4, excellent. This is your h value. This +1 is your k value. And that's your new vertex, like we do with the absolute value. So that would go in the middle of your table. Okay. And now, similarly, you choose a number less and then less again. So -5, -6. It's kind of like you're moving to the left there. And then forward and forward again. We won't do a lot of this, but you will do this as part of your last time I'll say it, right? Point plotting is actually a little bit elementary, but for right now, just a little bit for tonight's homework and on our first assessment. So once you have that kind of main point, we can sub in -5. Remember, it's the original function. This would become a -1. Squaring it becomes a +1. Adding 1 becomes a 2. Here's another graph that has symmetry, meaning I better get the same output here. If not, something's wrong. -3 + 1 is +1, squared is +1, add 1 is 2. Now you know you're 100% right. You know you got the symmetry going. Sub in -6, add 4 makes -2, squared becomes 4, add 1 becomes 5. This is going to output 5. I'm just going to omit plotting the points because you wouldn't be in this course if you couldn't plot points. But we go to your graph paper, ding, 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 or if you're on MyLab, just click them, type them in. But to further emphasize one last time, what's going on here? Y equals x plus 4 squared minus, my brain is +1, thank you. +1. There it is. There's our turning point. Just give it a little shade different there. So shift it over. And as you can see, the entire parabola shifts over that way. All right. Beautiful thing. All right. Let's kind of wrap up tonight, but we have a couple last transformations to look at. You can find the handout from the beginning of the class. We'll do it together. And if I can get you out a little bit early, I promise I will. So I'm going to spoil this because I think our brains are getting saturated and we're at the main point. This is still the main stuff, but you got it. So there's a couple more transformations. We're looking at it. A negative inside and a negative outside. So like the H and the K, but like the, there's not exactly, there's an inside negative and an outside negative. So if we sub in -1, we'd have f of negative and then this is my -1. Well, that's kind of ridiculous. A double negative is positive, So I'm really finding f of 1, going back to earlier today, Frank, that outputs 1. And f of negative, well, if I give it negative 2, it's kind of ridiculous, but I could. That's a weird looking negative sign. But negative of negative, that's really just 2. F2 is 3. I think you got the vibe of this. This is going to output 3. So we're going to plot this table that I'm looking at, x and f of negative x. So we plot negative 1, 1. Negative 2, 3. Negative 3, 3. And we kind of see the Big Dipper, except it's been what? It's been reflected over the y-axis. And that's the transformation. A negative inside of a function reflects it over the y-axis. I'll write that out in words in a minute. We're in the temporarily exploratory phase, but that's just what happens. It's a mirror image across the y-axis. To further emphasize that, if this is 1 unit to the right, then its mirror image across the y-axis is 1 unit to the left. From here, this was 2 units. Well, now it's 2 units in the opposite direction. And this one over here was 3 units away. Now the same height. That's going to be 3 away. Mirror image. We're just reflecting it over. Down here, this says negative in front and then f of 1. Okay. Frank, given 1, outputs 1. So this becomes 1 with a negative sign in front. Give it 2. Give this rule 2. Okay. 2 goes right there. Frank takes 2 and outputs 3. We've seen that all night. With a negative sign in front. And similarly, Frank takes 3, also outputs 3 with a negative sign in front. So it's like the same outputs, except a negative in front. So how can I say that? Same outputs with a different sign in front. They're opposite outputs. We're just switching the sign of the outputs. Meaning the same x, but the opposite y value. The same x, but the opposite y value. The same x, but the opposite y value. And I'm saying it that way after I just got through saying a mirror image over the y-axis. What does a negative do to a function when it's in front of it? It's a mirror image over the x-axis, or a reflection over x. Okay, you win, computer. You won't hear me say it anymore tonight, but it's like the Big Dipper, Little Dipper, right? That kind of shape, whatever. But now, again, not reflected over. It's not been shifted. It's literally a mirror image over that axis. So we'll summarize that. In a new spot. Come on, tablet. Both of these are reflections. I like to think of mirror images. But the inside one is over the y-axis, and the outside one is over the x-axis. Not much more to say about that. It's not a shift. That's not the same as shifting something, which moves the entire object. Instead, it's a mirror image across, or mirror image across. You need to use the word reflection if you're not catching what I'm trying to say to you. You have to say reflection. And when it's a shift, you have to say a shift. So shifting, reflecting, and the final transformation is hard to see, and I'm not going to do what I was originally planning. I'm going to switch to Desmos, and then we'll just summarize it. I'm going to use y equals absolute value of x again. And here's another cool thing about Desmos. Y equals, I'm going to say capital A, absolute value x. And so that this is super clear for you, I'm going to use the symbols. This is just literally a matter of watching. So in a minute, I'm going to put a slider for A, which is going to let me look at a lot of different values really quickly. So we're not seeing the graph yet because it's like, all right, there's an error. So if my slider is set to 1, which it is, we're looking at the same thing. Does that make sense to you? What number is in front here invisibly? 1. So it makes sense we're looking at the same graph. Who's following? There's a 1 in front. That's why right now it's the same graph. The blue and the green are the same overlapping graph. But if I take that multiplier to something bigger than 1, you still get a V-looking shape, but it becomes narrower. It's not a shift because that's still anchored at 0, 0. That's the biggest way to know you did not shift it. If you shift something, everybody moves. It's not a reflection. It is a vertical stretch. I don't like the word either. I don't know why we call it something like a vertical narrower or something, but we don't. We call it a vertical stretch. And the bigger the number, the more vertically stretched it becomes, or narrower. Let's go back to 1. Obviously, if you multiply by 1, you're looking at the actual object, the V graph. If it's a number like a proper fraction, a proper decimal, not 2.4, but 0.4. Oops, that was too much. Then we don't call it a vertical stretch. We call it a vertical compression, a vertical shrink. I don't know. Both, I do know. I just said what they are. It depends on the textbook, right? But basically, we'll stick with like a vertical compression. I like the word compression. But if you say shrink, I'll let it go. I'm not going to split hairs about which one is called. As long as you know this is definitely narrower, multiplying by 1 does nothing. Multiplying by a proper decimal, and I say proper decimal because 2.5 has to be between 0 and 1, is just going to make it look wider. We call that a compression or a shrink. You're good. Right. An inside multiplier. And spoiler alert, if you've had trig, this will look familiar to you. If you haven't had trig, we will build this. But it's just nice to see it this way. Something called a sine wave. You don't have to know that yet, right? Just know, hey, cool, there's a wavy looking graph. And if you know why it looks like that, because you've had trigonometry, cool. If you don't, it's all good. Just recognize, here's a sine wave. And here's an applied science. Music, heartbeats, I could go on forever. So many real world phenomena. I'm drawing a blank. But wave physics, right? So many things. Currency, like not money, but like currents and wattage and things I don't know a lot about, just a little bit, but I've seen the graphs in different fields. This is applied everywhere. But it's not just this wave, like it's a transformation of this wave. And one thing you might need to do is change its amplitude. So we just talked about the outside multiplier of A. So if A is 1, you're stretching it. Or if it's between 0 and 1, you're just making it more compressed. There's your outside multiplier. But what if we did an inside multiplier, B? So I'm going to get rid of A. See you later, A. You no longer exist. Watch the change here. It's not a shift. It's not a reflection. But it like changes what we call the frequency of the graph. But really what we're doing is stretching it horizontally or compressing it horizontally. Stretch horizontally like a slinky. You're like pulling this thing way out. And then you can shrink it or compress it horizontally, and you start making different sine waves. So you're not changing the amplitude, you're not shifting the graph, you're changing its frequency. So in closing, and then I'm done for tonight, the final transformations. You have A times a function versus B times the inside of a function. These are both stretches or compressions. I got 4 bullet points and we're done. This is a vertical stretch. If A is greater than 1. I'm going to say it's absolute value. This is a vertical shrink or compression. I'll just use the word shrink. That's a lot of symbols that just says proper fraction. Between 0 and 1 is a proper fraction, like 1/2, 3/4. Not 7/2, that's an improper fraction. That's a top-heavy fraction. No, proper fraction, proper decimals. If you have an inside multiplier, this is called a horizontal stretch. And I did not make a mistake there. We have 2 minutes. I'm done writing on my tablet. I'll let you get caught up. I'm not dismissing you before yet. But that's not a mistake. This is outside. When you multiply by 2, don't you feel like you're stretching your money versus shrinking it? If you have a bank account and you multiply it by 2, wouldn't you be saying you're not shrinking your bank account, you'd be stretching it. But when it's inside, 2 is not a stretch. It actually what caused, and I went so fast you didn't catch it, we will see it in the future, I'm just telling you the fact, that wave, 2 made it go like this. 2 is what compressed it. outside 1/2, if I take your bank account and I multiply it by 1/2, I definitely shrunk your money. But this is no mistake. Inside, 1/2 is what stretched it horizontally. So I leave you with this. We were struggling intentionally tonight with that h. It has to be what form? X minus h. What does that do to a graph? It shifts it. Which direction? Right or left? Right. Because it's x minus, and we associate 3 to the right. But if you can just hear my last little maybe study tip. If someone walked through that door right now, and they were somewhat educated but rusty, what are they going to associate when they see minus? To the right or to the left? So their instinct would be left, but we know it's right. Inside opposite. Inside opposite. You see this, your instinct says go to the left. Inside opposite, go to the right. Why am I saying that? When we see 2x, we're going to say, when you multiply by 2, you're stretching my bank account. But if it's inside, that's actually the opposite of my instinct. It's a shrink. It's not stretching it. We'll come back to that this next class a tiny bit because we're now overtime. The inside are kind of like opposite of what we instinctively believe. But the outside transformations follow nicely. I'll see you guys on Wednesday. Let me get my words right. And our first exam is a week from Wednesday. So Wednesday becomes our last topic. Whatever we cover on Wednesday becomes the end of exam 1. So we'll go from there. You can keep that stuff. Yep. See ya.
So to me, everything inside the parentheses is effectively x. Everything outside the function is effectively y. So if you add
Yes.
a multiplier to the f